All right, so today we are diving deep into a really specific corner of system architecture. We're talking about specialized video routing.
Yep.
Specifically, we're looking at this one device, the NTI SM-8X2-15V-LC. It's a VGA video matrix switch.
Right.
And our mission today is really to figure out how places, big organizations, reliably get video from a bunch of different computers to exactly where it needs to go.
Without turning it into a blurry mess.
Exactly.
And that model number, the SM-8X2-15V-LC, it kind of gives the game away right up front. 8 inputs, 2 outputs. Simple as that.
Okay, 8 computers to 2 displays, but the interesting part's the matrix, right?
That's the key. This idea of a matrix pattern of interconnection possibilities. It isn't just a simple A-B switch. Any of those 8 sources can connect totally independently to either of the 2 displays.
Or both at the same time.
Or both simultaneously.
Okay, wait a minute. We're talking about analog VGA here. If you're routing one signal to 2 different places at the same time, aren't you going to have huge impedance issues? Signal reflection, crosstalk, all that nasty stuff.
That is the entire engineering challenge they solve. And you're right to ask that. The switch doesn't just split the signal passively. It actively buffers each video output.
So it's not just a dumb splitter. It's actually processing the signal.
It's regenerating it. It's doing active equalization, re-amplification. The image you see is as crisp and clear as if you were plugged directly into the source. No ghosting, no color shift.
Okay, so if the signal integrity is really that solid, what kind of performance specs are we actually seeing here?
The specs are pretty impressive for this kind of gear. You're looking at a video bandwidth of 200 megahertz or even a little more.
Oh.
But the number that really matters is the resolution support. It can handle 1920 by 1200 at an 85 hertz refresh rate.
And that 85 hertz is important, isn't it?
It's crucial because at those high refresh rates, any flaw in the system, any poor shielding, it shows up immediately as flicker or noise. This spec guarantees 0 degradation. That's a must-have for critical applications.
Yeah, you can't have flicker in a control room. And they've stuck with the standard 15-pin HD connectors, just normal VGA cables. I remember having to use BNC coax for complex video walls. It was a nightmare.
Oh, yeah.
So just using standard cables is a huge win for simplicity and just getting things set up fast.
It really is. The hardware itself is clearly resilient, but for the people actually using it, the big question is always, how do I control it?
Right. What are the options?
Well, they give you a whole menu. You can use the buttons right on the front panel. There's an LCD screen there. It comes with a little IR remote.
Okay, basic stuff.
But then you get into the pro level control. It has a serial port, and for big deployments, it's got an Ethernet port, so you can control it over the network with their GUI software.
So total redundancy in control methods. That makes sense.
And that flexibility that connects directly to where you'd actually use this thing. I mean, think about the so what here. Why do you need 8 sources on tap?
Command centers, I'm guessing.
Exactly. Command centers, control rooms. You might have one source, say a sensor feed, that you need to route to a monitor showing just the raw data.
Okay.
But at the same time, you need to route that exact same feed to a second monitor that's showing, I don't know, a processed geomapped analysis of that data. You need that quick, reliable switching. It's non-negotiable.
And I saw that they burn-in test every single unit for at least 24 hours.
Yeah, with heat testing. It's all about confirming it's ready for those demanding, always-on environments.
So the bottom line here is you've got this robust 8x2 video routing. It regenerates the signal so it's perfect, high-res performance is guaranteed, and you have a ton of ways to control it.
That's the core value prop right there.
Okay, so let's push this a bit further then into the next level of system integration.
Sure. If you dig into the source material, they mention you can combine this switch with other NTI products, specifically something called a VGA EDID emulator.
An EDID emulator, what does that do?
In short, it tricks the source computer into thinking a specific monitor is always connected perfectly. So your computer never gets confused about what resolution to output, even when you're switching connections on the fly.
So it prevents that flicker when the screen resolution has to renegotiate.
Exactly. It keeps the handshake smooth. So that brings us to the final thought here for you to think about. If one of these switches can reliably manage 8 sources, how does adding a specialized piece of tech like that EDID emulator, allow system managers to scale this whole matrix idea up to manage not just 8 connections, but maybe thousands across a massive, complex, even global network?
That's the real architecture puzzle.
It's the puzzle this technology helps solve.